Free Physics MP3 from cg4u.net for students. Source: Wikipedia. Electromagnetic radiation. Electromagnetic radiation (EM radiation or EMR) is a form of energy emitted and absorbed by charged particles, which exhibits wave-like behavior as it travels through space. EMR has both electric and magnetic field components, which stand in a fixed ratio of intensity to each other, and which oscillate in phase perpendicular to each other and perpendicular to the direction of energy and wave propagation. In a vacuum, electromagnetic radiation propagates at a characteristic speed, the speed of light. Electromagnetic radiation is a particular form of the more general electromagnetic field (EM field), which is produced by moving charges. Electromagnetic radiation is associated with EM fields that are far enough away from the moving charges that produced them, that absorption of the EM radiation no longer affects the behavior of these moving charges. These two types or behaviors of EM field are sometimes referred to as the near and far field. In this language, EMR is merely another name for the far field. Charges and currents directly produce the near field. However, charges and currents produce EMR only indirectly. Rather, in EMR, both the magnetic and electric fields are produced by changes in the other type of field, not directly by charges and currents. This close relationship causes the electric and magnetic fields in EMR to stand in a fixed ratio of strengths to each other, and to be found in phase, with maxima and nodes in each found at the same places in space. EMR carries energy, sometimes called radiant energy, through space continuously away from the source. This is not true of the near field part of the EM field. EMR also carries both momentum and angular momentum. These properties may all be imparted to matter with which it interacts. EMR is produced from other types of energy when created, and it is converted to other types of energy when it is destroyed. The photon is the quantum of the electromagnetic interaction, and is the basic unit or constituent of all forms of EMR. The quantum nature of light becomes more apparent at high frequencies or high photon energy. Such photons behave more like particles than lower frequency photons do. In classical physics, EMR is considered to be produced when charged particles are accelerated by forces acting on them. Electrons are responsible for emission of most EMR, because they have low mass, and therefore are easily accelerated by a variety of mechanisms. Rapidly moving electrons are most sharply accelerated when they encounter a region of force, so they are responsible for producing much of the highest frequency electromagnetic radiation observed in nature. Quantum processes can also produce EMR, such as when atomic nuclei undergo gamma decay, and processes such as neutral pion decay. EMR is classified according to the frequency of its wave. The electromagnetic spectrum, in order of increasing frequency and decreasing wavelength, consists of radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, 10 rays and gamma rays. The eyes of various organisms sense a small and somewhat variable, but relatively small range of frequencies of EMR called the visible spectrum or light. The effects of EMR upon biological systems and also to many other chemical systems, under standard conditions, depends both upon the radiation's power and frequency. For lower frequencies of EMR up to those of visible light, i.e., radio, microwave, infrared, the damage done to cells and also to many ordinary materials under such conditions is determined mainly by heating effects, and thus by the radiation power. By contrast, for higher frequency radiations at ultraviolet frequencies and above, i.e., 10 rays and gamma rays, the damage to chemical materials and living cells by EMR is far larger than that done by simple heating, due to the ability of single photons in such high frequency EMR to damage individual molecules chemically.